Lab 12 is talking about parallel execution. The objectives that we are going to cover in Lab 12 includes the understanding of parallel execution. We will also discuss what are the SQL statements that can be parallelized and set the degree of parallelism. So these are the three things that we are going to look into Lab 12. Let's proceed now. Now let us understand what is parallel execution. The parallel execution is actually the idea of dividing a big task into smaller tasks so that these smaller tasks can be run in the same time. We can put it also like this. We can divide a big query into smaller chunks, and to each chunk of execution, we provide a server for it. So it is like four servers working on a query which is parallelized at the level 4. It simply means that a big query is divided into 4 parts, and these 4 parts are run together. So we say that the parallel execution is the idea of breaking down a task. It can be a query, it can be creating an index, it can be creation of large tables, or executing bulk inserts, updates, merges, and deletes at the same time. For example, if you create the students table for a university, and we know that the university have thousands and thousands of students. So you want to insert the details about or update the results about these thousand and thousand students at the time of exams, and doing that process or executing the script which updates the final exam grades for all the students in the banner will take a lot of time. In this particular case, what we can do is we can set the parallelism level for insertion. Maybe you can say that, yes, I need 4 servers to work on a simple bulk insert, which is involving thousands of students update or insert details at the same time, so that the processing times gets faster in terms or by the degree of, four times faster. So, this is the aim of parallel execution, dividing the big task into smaller tasks and executing these smaller tasks at the same time. Parallelism improves the processing for queries requiring large table searches, joins, or partition index scans. It can also help you in the case of creating large indexes, in the case of creating large tables, and inserting, updating, merging, and deleting the rows in a bulk form. So these are the 4 places where parallelism can help us. The interesting thing is that this feature is only available with Enterprise Edition. It doesn't come with the Standard Edition, or it doesn't come with the Express Edition. Okay. Now, the 4 things that can be parallelized or that can perform the execution in a parallel way includes all the DML commands and rebuilding of indexes, okay, index scans, and backup and recovery. Let's see how does it do, or how does it parallelize the DML, data manipulation language commands. We know that DML includes insert, update, and deletes. So we can have insert, updates, and deletes in parallel. As I told you that if we want to update the grades of thousands and thousands students inside the university at the time of final exam, we can parallelize that update command. Okay. Now, the second one is parallel index rebuilding. These includes those features that allow to, parallelize large creation of large indexes, or it can be rebuilt in a fraction of time requiring by a single CPU system time. It means that, creation of indexes can also be parallelized, and multiple servers can be assigned to create a single index, okay, by dividing this single index into smaller parts and assigning each server to this smaller part, so that the creation of index takes place parallelly or concurrently. Index scans. This feature allows for parallel fast index searches and multi-block reads of index blocks data. The backup and recovery can also be performed in a parallelized uh, fashion by allowing the Oracle RMAN. Okay, so what is an RMAN? RMAN is a recovery manager tool provided by SQL. So when we want to take a backup of the database, we need to use this RMAN. Okay, so the working of RMAN can also be parallelized to give you fast backups of large databases. Taking the backup of large database is a time-consuming job. That is the reason why you will get an alert from Riyadh Bank or some another bank, okay, which tells you that the database is going to be or the system is going to be maintained, and the maintenance activity will take place from maybe in the weekend, okay, from from specific times of the period, like including 8 hours or 10 hours, and then they say that in this time you will not be able to access the online services. So basically what are they doing? They are maintaining the database and they're creating a backup of the database. So creating a backup or a copy of the database that serves as a backup is a time consuming job. It takes a lot of time to create a backup database. So now in order to make this backup faster, we can parallelize the backup and recovery process by allowing the Oracle RMAN to run in the same time on multiple tasks. So let us now, that was about the parallel and backup. Parallel backup and recovery. Now, DDL statements can also be parallelized. Okay, what do we mean by that? The DLL commands, the data definition language commands, includes the creation of index, creation of tables and views, and creation of index, altering the index and rebuilding the index. So these things can also be parallelized, or we can have multiple servers assigned to the creation of a very big table to fast the process. Okay, now let us see the DLL statements for partition tables and indexes are given here. Altering the tables, altering the index rebuilds partitions, creating partition inside the index. We will see what is partition, in a different lab. Okay, so creation of indexes and creation of table. Okay, so all these things can be parallelized. Now let us see how to do that. We have been telling that DLL commands and DML commands and backup and recovery process can be parallelized. But let's see how to do that. It can be done in two ways. Okay, one by using the parallel command or parallel clause at the statement level, or by using the hints. Okay, we are going to see how to parallelize the commands by using parallel clause in this particular lab. The degree of parallelism may be specified in, one, two ways at three levels. Okay, we can do the setting of parallelism by these two ways, but at these three levels. Okay, once the parallel level or the parallel clause or the idea of parallelism can be applied at the session level. Okay, or it can be applied at a table level, or it can be applied at an index level. Now, when we apply the parallel idea or parallelized idea at the session level, it means that whatever I will do or whatever action I will perform inside the session will all have or will all take the advantage of parallelism. How do we do that? We do that by using a command like alter session force parallel. So this is the statement that we will use. So if you remember, we have been using the alter command to set the session. Alter session set the container is equal to xepdb1. Okay, so now we have alter session force parallel, and then we apply this session to become or to behave in a parallelized way. It can also be done by allowing the parallelism on a specific table. Okay, so we will see how to do this in this particular lab, like making a table work in a parallel way. Okay, so we do that by using the table level definition. Okay, and using the parallel clause with it. How to do this? You can see here, alter table. Okay, students parallel one. No, with parallel one, we don't have parallel two, means, allocating two servers or dividing the table task into two parts and executing them in the same time. Okay, so here this one, alter table, students parallel, four means dividing the whole table creation process into four smaller parts, and each part is actually taken care by a separate server or a process. Okay, so that the creation of table becomes faster in terms of, four times better than before. Okay, so this is the second way. The other way is we can apply the parallelism at the index level. Okay, so we will see this in the example. So these are the two things that we are going to do today. Okay, the activity one, very simple. Alter the table, okay, to parallel 4. Okay, alter the table to parallel 4. We say alter table, name of the table. Okay, it can be students, it can be employees, it can be any table. Okay, so you're going to say alter table, students, for example, apply parallel 4. What does it mean? It means that the above statement will set the degree of parallelism to how much? It will set the degree of parallelism to 4. This is the first thing. The second thing that it does is it actually create this, table into four concurrent tasks, meaning that the operation involving this table can be divided up to four smaller tasks that can run at the same time. So processes that run in the same time are called as concurrent processes or concurrent tasks, potentially speeding up the data manipulation and query operations that are to be performed on students table or students data set or students database can now work four times faster. Why? Because uh, uh, the four parallel execution servers are active on this particular statement because we said four. So four parallel execution servers are active here. So it's like, for example, I give you an assignment and I say that three students can do this assignment. So what happens? It only means that alter assignment students parallel three. It means three students are going to work on an assignment. The assignment finishes faster, right? So this is the job of using the benefit of or the benefit of parallel 4. Okay, so that completes our discussion on lab 12. Thank you.